The CLO for this lesson is that students will be able to graph in writing equations using the parent function and translations up and down, as well as the following language, if then statements, parent function, transformation, translation, and vertex. In your own words, what do you think you're going to learn how to do in this lesson? So to begin with the vocabulary, a parent function is the main function of a family that identifies the shape the graph makes. So here's the thing about the parent function though. So in the last lesson, we learned all about the parent functions and learned about the shape that their graphs make. However, all of them can be transformed. Now, a transformation is a way we change a shape. So there's tons of ways we can change shapes, and you're going to learn about all of them. Part 1 is about translations up and down. So the word translation is just a big word for a move. So in this lesson, we're going to work on moving graphs up and down. And when we're moving them, it's easiest to just move the vertex. In a quadratic, remember, is the hump, where it humps. So for x squared, this vertex for the parent function's at 0, 0. If you remember, all of the parent functions go through 0, 0, all of them but constants. So for right now, we're going to call the vertex the 0, 0 of the parent function. So for the sake of this unit, that's what the word vertex is going to mean. It's where the 0, 0 of the parent function is, and we move that point around. So transformation number 1 that we're going to focus on is translating up. So when it comes to translating up, the question here says in an equation, what causes a function to translate up? And the answer to that question is when we add something to the end of the equation. So let me show you an example. This x squared plus 3, this plus 3 is going to make me translate my x squared up 3. It's going to move it up 3. Let me show you. Here's x squared. Here's x squared plus 3. See how the whole graph went up 3? So like this vertex was down here at 0, and then it moved up there to 3. See that? If I were to take the parent function, which is x squared, and plug in -1. -1 squared means -1 times -1, which ends up being +1. So let's do the parent function in purple. So if I were to plot that point, -1, it's right here at +1. But in green, I'm going to do the new one when I add 3 to it. If I take 1 and I add 3 to it, now I'm going to be at 4. So my new one with the +3, the dot gets moved up 1, 2, 3, and I'm up here at 4 now. If I plug in 0 to my parent function, 0 times 0 is just 0. Then when I add 3 to it, now I'm at 3. So for my original one, my parent function, it's down here at 0, 0. But for my transformed one, now I'm up at +3 because I'm going up 3. When I plug in 1, 1 times 1 is just 1 for the parent. So that's down here. But then if I add 3 to it, now I'm at 4 for my f of x, my new one that I'm graphing. So because it's a quadratic, what shape is it going to make? I need to connect my dots and make the parabola shape where it kind of U's. So the green one's my answer because the purple one was my parent function, but because I translated it up 3 because of this plus 3, then the green one's my new graph, the one that they wanted me to graph because the instructions are to graph this f of x. So this would be the right one. However, using a table is the long way to go. The easiest thing to do is to remember that the parent function, x squared, has these 3 points where there's the vertex in the middle at 0, 0, and then when you go right and left for both of them, they go up 1, and you get your dots. So then if the plus 3 is telling me to translate it up 3, I just take all of my dots up 3. So I take my middle one up 3, and then I go over 1, up 1, over 1, up 1, and put those 2 dots right there. Then I make my shape. So again, move the 0, 0, the vertex, up 3. Then go right 1, up 1, and left 1, up 1. And then you make your shape. And then you make your shape for the parent function. So an easier way to do it, that's much faster than making a table like this, is to just ask yourself, what are the transformations that I see? Well, this part's the parent function part, and the transformation's the plus 5. And because it's at the end, since it comes like after the parent function, this means to translate up 5. So I'm gonna translate up 5, but which graph? What's my parent function in this equation? The parent function's absolute value. And what shape does the absolute value graph make? It makes a V shape. So if we look at the basic absolute value graph, it also has 0, 0, and then you're gonna go right 1, up 1 for 1, 1, and left 1, up 1. So it's just like the quadratic graph. It has the same 3 points, except instead of making a U like the quadratic graph does, see how it goes with the same 3 points? But instead of making a U like the quadratic graph, it makes a V. So how I'm gonna graph it is I'm gonna take my 0, 0 point, and I'm gonna go up 5. 1, 2, 3, 4, 5. And there's my new 0, 0. I've moved that vertex. Then I'm gonna go over 1, up 1, and then also over 1 towards the left and up 1. Finally, I have to make the right shape, the V shape for my graph. And I'm done. I've graphed it. Look, if I look over here and say plus 5, there's the graph, just like you have it in the notes. Try to make it as perfect as V as you can when you make the graph. And so that's the fast and easy way to do this one. One thing to note is that sometimes they use this weird notation where they will tell you the parent function first. Like they say, look, f of x is the absolute value. Then they're going to say graph that f of x plus 5. Well, it's the exact same thing as this one. If I put absolute value of x plus 5, they just wrote it where they wrote it like this instead. But the answer would still be this graph. You just take the absolute value of x and then you translate it up 5. The second transformation to learn is to translate down. So the question of in an equation, what causes a function to translate down? The answer is a number being subtracted from the end of the equation. So for translate up, it's adding at the end, it's going up. But if it's subtracting at the end, then it's going down. So for this one, if you see the -3 at the end, the transformation is what? We need to translate down 3. So what's the parent function in this equation? When there's an x to the power of 3, it's called a cubic. And what shape does the graph of a cubic make? Remember, it does an up and down sort of S type of shape. So if I were to graph this cubic, and so it kind of has this up and down S type of shape. However, note that it has the point 1, 1, just like the quadratic in the absolute value. However, the -1 doesn't go up to 1. Instead, it's going down to -1. So if I want to graph this, I'm going to take my vertex. I'm going to translate it down 3. So from 0, 0, I'm going to go down 1, 2, 3, and put my first dot. Then for this one, for the cubic, when you go right 1, you go up 1. And then from that vertex, it's left 1, down 1. And then I make the right shape. So because it's a cubic from my vertex, I go up on that side, and then I curve down on this side. So that's how I'd graph this one. This was my example. What's the transformation? It's telling me to translate down 5 because of the -5 at the end. What's this parent function? Remember, this little symbol means the square root. What's the shape for the square root graph? Remember, it's the top half of the sideways U, which kind of goes like that. So if I were to just graph the basic square root of x, that's what it looks like. This one has a point at 0, 0 and a point at 1, 1, but it doesn't have any of the -1 point, like that third point over here. So this one, you only need 2 points to make the graph. You need the 0, 0 and the going right 1, up 1 point, the 1, 1. So first, I take it and I translate it down 5. So from 0, 0, I'm going to go down 1, 2, 3, 4, 5, and put my new vertex. Then this graph goes over 1, up 1. Then I just have to make the right shape, that square root shape. And there's my graph of this one. So again, they can give you this notation where instead of saying graph this, they'll say f of x is the square root of x, so graph f of x minus 5, which just means take the square root of x and translate it down 5, which is the same thing as this, just different notations. So let's talk about the points you have. For all parent functions, the major points to plot. So our parent functions we have that we're going to be translating is we have quadratics, square roots, cubics, cube roots, and absolute value. We're not going to be translating linears or constants because you learn linears in year 1 and constants don't really get translated. For these 5, we're going to be graphing these 5 using the transformations. So the major points to plot for a quadratic, remember quadratics are x squared. It has the first one at 0, 0, the vertex, which originally starts at 0, 0, but it can get moved. Remember, it doesn't always stay at 0, 0. The second one I can always plot, and it doesn't matter which one you do first after the 0, 0. But from here, we would normally go over 1, up 1 to get this 1, 1. So it'd be right 1, up 1. No matter where I move my vertex, no matter how far up or down it goes, my second point is always from going also right 1 and then up 1. So my second point is going to be right 1, up 1. And then the third point that's important to plot is this one over here. So that's going left 1 and up 1 for a quadratic. Both of these are from the vertex, like wherever it moved to. So it's like first you move your vertex at 0, 0 points. And then from wherever it goes, you do right 1, up 1, and then left 1, up 1 for your next 2 dots. For square roots, it's almost the same 3 points. So if I type in square root of x, there's the 0, 0. I do go right 1, up 1 to get that dot right there. But there's no third dot. There's no left 1, up 1. So for the square root, you only need to do those 2 points. For cubic, remember cubic is x to the power of 3. This one has 0, 0. It goes right 1, up 1. But when it goes left 1, it's not going up here. It goes down 1, down here. So for cubic, it's almost the same 3 points. Instead of left 1, up 1, this time it's going to go down. For cube roots, there's 0, 0. There's 1, 1. So it goes right 1, up 1. And it also goes left and down, just like the cubic. So cube root has the same 3 points as cubic. The only difference is going to be the shape you make. So with cubic, you are going to go up and down. So you'll go up and down like the purple one versus going side to side like that green one. But still, they both have these points, the same 3 points in them. It's just how you draw it after that. And the last one, the absolute value. It has 0, 0, right 1, up 1. And then when I go left 1, it goes up 1, just like the quadratic. So it has the same 3 points as the quadratic. Instead, it's going to be quadratics slash absolute values that have these 3 points instead of listing it again down here. And in the same way, cubic and cube root have the same 3 points. So there's no need to list it twice. So those are the major points to plot whenever you're graphing any of them, any of the 5. Where you always start with moving your vertex. So wherever your vertex is, you're going to translate it first. You're going to translate it based on the transformations in the equation. And then you're going to plot your second and third dot by doing this from your new vertex. From new vertex. From new vertex. Same thing here. You take that vertex at 0, 0 and you translate it based on the equation. Then you're going to go right 1, up 1 from the new vertex. And for these two, you also translate it based on the transformations in the equation. And then you're going to go right 1, up 1 from the new vertex, and then left 1, down 1 from that new vertex. So this is how you graph all of them in the easiest, quickest way. So now, using the vocabulary words, parent function, transformation, translation, and vertex, as well as if-then statements, explain what you learned how to do in this lesson.